What if the universe isn't just a vast, silent expanse of stars and galaxies, but something far more alive, far more conscious than we've ever dared to imagine? Picture this: every thought you've ever had, every moment of awareness, every spark of curiosity might not just be happening inside the universe, but as the universe itself awakening. This isn't science fiction. It's a radical idea at the edge of science and philosophy, one that suggests we're not merely inhabitants of the cosmos, but its very way of understanding itself. And if that sounds mind-bending, well, it's because it is. Look up at the night sky, and you're gazing at a tapestry of creation over 13 billion years in the making. Stars born and dying, galaxies colliding, black holes humming with invisible energy. But what if all of that grandeur isn't just happening randomly? What if it's part of a deeper story, one where matter organizes, complexity grows, and eventually, life emerges not as an accident, but as a kind of cosmic inevitability? Think about it. The same atoms forged in the hearts of ancient stars now make up your body, your brain, your ability to wonder about the universe. In a very real way, the cosmos has evolved to the point where it can look back at itself through you. This is the heart of cosmic evolution, the idea that the universe isn't static but alive with potential, unfolding in ways that might just include us as its most profound expression. Over the next few minutes, we're going to explore what that really means. From the latest breakthroughs in physics to the frontiers of consciousness studies, we'll uncover how science is beginning to catch up with this breathtaking possibility. And along the way, we'll ask the big questions. Are we the universe becoming self-aware? Is human curiosity itself a kind of cosmic mirror? And if so, what comes next? Strap in. This journey is about to redefine how you see yourself, the stars, and everything in between. To understand cosmic evolution, we have to rewind the clock, all the way back to the very beginning. In those first fleeting moments after the Big Bang, the universe was a searing ocean of energy, too hot and chaotic for even atoms to form. But as it expanded and cooled, something remarkable happened. Simple particles began clumping together, drawn by gravity, sparking the birth of stars and galaxies. Over billions of years, those stars forged heavier elements in their cores, seeding the cosmos with the building blocks of planets and eventually life. This is cosmic evolution in action, the universe transforming itself step by step from raw energy to swirling galaxies, from stardust to sentience. It's not just about matter rearranging itself randomly. There's an undeniable direction here, a trend toward complexity. Think of it like a river carving a canyon, countless small interactions over immense stretches of time, creating something breathtakingly intricate. In the same way, the universe seems to follow a hidden current, pushing toward greater organization, richer structures. And at some point, that current led to us, creatures who don't just exist but question, create, and reflect. That's where things get truly fascinating, because if cosmic evolution has a trajectory, if it moves from simplicity to complexity, from chaos to consciousness, then human awareness might not be a fluke. It could be the universe's way of opening its eyes for the first time. Consider this: every time a scientist peers through a telescope or a child marvels at the night sky, the cosmos isn't just being observed, it's observing itself. The hydrogen atoms born in the Big Bang, the carbon forged in dying stars, they've now become minds capable of wondering about their own origins. It's as if the universe spent billions of years constructing a mirror just to finally see its own reflection. And that raises a haunting possibility. What if we're not just living in the universe, but we are the universe awakening to its own existence? This idea stretches across disciplines from physics to philosophy. Some scientists call it the self-aware universe hypothesis, while others frame it as the next logical step in cosmic evolution. After all, nature tends to build upon its own breakthroughs. Single cells became multicellular life, plants gave way to animals, and now, perhaps intelligence is the universe's latest experiment in complexity. And if that's true, then human curiosity isn't just a personal trait. It's the cosmos asking itself, what am I? How did I get here? We might be the universe's way of seeking answers. Now, let's take this idea even further. What if life on Earth wasn't just a local phenomenon, but part of a much grander cosmic pattern? Enter panspermia, the theory that the seeds of life didn't originate here at all. Instead, they hitched a ride on asteroids or comets, traveling across the void of space before landing on our planet billions of years ago. Think of it like a cosmic relay race where life's building blocks, amino acids, organic molecules, were passed from one corner of the universe to another, just waiting for the right conditions to take root. This isn't just speculation. We've found these organic molecules on meteorites, frozen in the icy depths of space, even in the dusty tails of comets. In 2020, researchers discovered glycine, a simple amino acid, in samples from the asteroid Ryugu, proof that the ingredients for life are scattered throughout the cosmos, like breadcrumbs leading back to a universal recipe. And if life's raw materials are everywhere, then maybe Earth isn't special. Maybe it's just one of countless incubators where the universe experiments with existence. Here's where it gets even wilder. If panspermia is real, then life might not be an earthly accident. It could be written into the very fabric of cosmic evolution. Imagine the universe as a gardener, scattering seeds across galaxies, nurturing them in pockets of warmth and water. Over billions of years, those seeds sprout, evolve, and eventually grow into self-aware beings who look up at the stars and wonder, where did I come from? In a way, we might be the universe's way of cultivating its own understanding, one planet at a time. This idea reshapes how we see our place in the cosmos. If life can travel between stars, then the line between us and the universe blurs even further. We're not just made of stardust, we might be part of a vast, interconnected web of biology stretching across light years. And that raises a thrilling question. If life arrived here from elsewhere, where else has it taken hold? Are there other minds out there, gazing at their own night skies, tracing their origins back to the same cosmic seeds? Panspermia doesn't just connect us to the universe, it suggests a shared destiny. Every cell in your body, every thought in your mind, could be part of a billion-year-old journey that began in the hearts of distant stars. So the next time you feel small under the night sky, remember, you're not just a speck in the universe, you're the universe reaching back to touch its own origins. But if life and consciousness are woven into the fabric of cosmic evolution, then why does the universe seem almost perfectly tailored to allow our existence? This is where the Anthropic Principle comes in, a concept that straddles the line between science and philosophy. In its simplest form, it suggests that the universe's fundamental constants, the speed of light, the strength of gravity, the charge of an electron aren't arbitrary. They're precisely fine-tuned to create the conditions necessary for life. Change just one of these values by a fraction, and stars wouldn't ignite, atoms wouldn't bond, and life as we know it would be impossible. The weak version of this principle states that we can only observe a universe capable of producing observers like us. It's a bit like a fish marveling at how perfectly water suits its gills. Of course it does, or the fish wouldn't be there to notice. The strong anthropic principle takes this further, proposing that the universe must, in some sense, be compelled to produce conscious life. This isn't just about luck or coincidence, it hints at something deeper, as if the cosmos had intention written into its blueprint. Imagine a lock with 1 billion possible combinations, and only one opens the door. The weak anthropic principle says we happen to find the right combo. The strong version whispers maybe the lock was designed to be opened. This idea sparks fierce debate. Skeptics argue that we're seeing patterns where none exist. that among countless possible universes with different laws, we simply inhabit the one where conditions aligned by chance. But others counter that the odds are astronomically against such perfection. The cosmological constant, for example, is so precisely calibrated that even a slight shift would have prevented galaxies from forming. Coincidence or cosmic craftsmanship? The answer might reshape how we see reality. Think of it like this: if you found a pocket watch in the desert, you wouldn't assume it assembled itself by accident. Its gears fit too precisely, its purpose too clear. The universe's fine-tuning raises the same question. Are we the result of an unfathomable roll of the dice, or is there something more at play, a deeper layer of existence where consciousness isn't just a byproduct but the point? This isn't just metaphysical musing. Cutting-edge physics grapples with these questions too. String theory proposes a multiverse, a vast ensemble of universes, each with different physical laws. In this view, we're simply in the one universe where life could arise, making fine-tuning a statistical inevitability. But here's the twist: if the multiverse exists, it pushes the mystery up a level. Why does any reality allow for universes where life is possible at all? The Anthropic Principle doesn't offer easy answers, but it reframes the conversation. Whether you see it as a cosmic shrug or a clue to deeper meaning, one thing is clear: our existence isn't just a footnote in the universe's story. We're part of a dialogue between matter and meaning, between the laws of physics and the fact that those laws allow us to ponder them. And that, in itself, is a revelation worth exploring. Imagine our planet not just as a rock hurtling through space, but as a vast, breathing entity, one that regulates its own temperature, maintains its atmosphere, and even heals its wounds over time. This is the heart of the Gaia Hypothesis, first proposed by scientist James Lovelock in the 1970s. He saw Earth not as a passive stage for life, but as an active participant, a complex, self-adjusting system where living organisms and their inorganic surroundings evolve together like a single living organism. Picture the way your body sweats to cool down or shivers to warm up. Now scale that up to planetary dimensions: forests absorbing carbon dioxide, oceans circulating heat, microorganisms stabilizing soil, all working in concert to keep Earth hospitable for life. Lovelock's radical idea was met with skepticism at first. How could a planet, a collection of rocks, water, and gases, behave like a living thing? But the evidence is hard to ignore. Take oxygen levels, for example. For billions of years, Earth's atmosphere has maintained just the right amount of oxygen to support life. Not too little to suffocate us, not too much to turn the planet into a tinderbox. This balance isn't luck. It's the result of countless interactions between plants, animals, and geological processes, all fine-tuned over eons. Even wildfires, which seem destructive, play a role in recycling nutrients and clearing space for new growth. The more we study Earth, the more it resembles not just a home for life, but life itself. Now, stretch this idea to cosmic scales. If Earth functions like a living system, could the universe be doing the same on an unimaginably grander stage? Think of galaxies as neurons in a vast cosmic brain, black holes as regulatory mechanisms, dark energy as the unseen force maintaining equilibrium. Just as Earth's biosphere self-regulates, maybe the universe evolves toward balance and complexity, with consciousness as its ultimate feedback loop. After all, what's the difference between a rainforest recycling water and a star forging elements needed for planets? Both are systems sustaining the conditions for something greater to emerge. This perspective flips how we see our place in existence. We're not just living on Earth, we're part of Earth's living process, and by extension, we're part of the universe's unfolding story. When a tree absorbs sunlight, it's harnessing energy from a star millions of miles away. When you breathe, you're exchanging atoms with the atmosphere that ancient microbes helped shape. Every thought you have is made possible by a chain of cosmic events stretching back to the Big Bang. You're not just in the universe, you're how the universe experiences itself. The Gaia Hypothesis doesn't just redefine Earth, it hints at a profound truth that life and its environment are inseparable, co-creating reality at every scale. And if that's true here, why not everywhere, from the tiniest microbe to the largest galaxy? Perhaps the universe isn't just full of life, perhaps it is alive. Not in a mystical sense, but in the way a vast, interconnected system thrives, adapts, and maybe even wonders about its own existence. And that raises one last, exhilarating question. If Earth is awake and we are its eyes, what else is out there just beginning to open its own? What if consciousness doesn't emerge from the brain's neural chatter alone, but from something far stranger hiding in the fabric of reality itself? Enter the world of quantum consciousness, where the rules of the microscopic realm might hold the key to self-awareness. At the heart of this idea lies a radical proposal that quantum mechanics, the physics governing particles smaller than atoms, could be the missing link between mind and cosmos. One of the boldest theories comes from physicist Roger Penrose and anesthesiologist Stuart Hameroff. Their arch or model suggests that consciousness arises from quantum vibrations inside the brain's microtubules, tiny protein structures within neurons. These vibrations, they argue, don't just process information, they collapse quantum possibilities into concrete experience, moment by moment. It's a wild idea, but consider this. Anesthesia works by shutting down these microtubule vibrations, temporarily halting consciousness without killing brain cells. If awareness were purely a product of electrical signals, why would targeting these tiny structures erase it completely? Penrose and Hameroff propose that consciousness isn't just computational, it's a quantum phenomenon woven into the universe's deepest layers. And if that's true, then the line between your thoughts and the cosmos starts to blur. Now, stretch this concept beyond the human brain. If quantum processes can birth consciousness in us, could they do the same on a cosmic scale? Some scientists speculate that the universe itself might possess a form of quantum awareness, not as a centralized mind, but as a web of entangled particles exchanging information instantaneously across vast distances. This isn't mysticism, it's grounded in quantum entanglement, where particles remain connected no matter how far apart they are. Change one, and the other responds faster than light should allow. Einstein called it spooky action at a distance, but what if it's more than just physics? What if it's the universe's way of maintaining a silent, seamless conversation with itself? Critics argue that quantum effects are too fragile to survive the warm, wet chaos of the brain, let alone scale up to cosmic consciousness. Yet recent discoveries show quantum phenomena in photosynthesis, bird navigation, even our sense of smell. Life seems to exploit these quantum quirks in ways we're only beginning to understand. And if biology harnesses quantum mechanics, why not the universe as a whole? Here's where it gets even more intriguing. The arch or theory ties quantum collapse, the moment particles choose their state, to consciousness itself. Penrose suggests that gravity, warping spacetime at the quantum level, triggers these collapses. In other words, the universe's structure might be intimately tied to how awareness arises. Imagine that every time you make a decision, the fabric of reality shifts slightly to accommodate it. Your thoughts could be tiny ripples in the quantum field, part of a vast, interconnected dance of matter and meaning. This isn't just about human minds. If consciousness is a fundamental feature of reality, like gravity or electromagnetism, then stars, planets, even black holes might participate in some cosmic form of sentience. Not as we know it, but as a spectrum of awareness stretching from atoms to galaxies. The universe wouldn't just contain life, it would be alive in ways we're only starting to glimpse. So the next time you pause to wonder, remember, your curiosity might not just be a product of the universe. It could be the universe wandering through you, one quantum flicker at a time. If the universe is teeming with the potential for life, why does it seem so eerily quiet out there? This is the essence of the Fermi Paradox. the puzzling contradiction between the high probability of extraterrestrial civilizations and the complete lack of evidence for their existence. Named after physicist Enrico Fermi, who famously asked, "Where is everybody?" this paradox haunts our search for cosmic neighbors. With hundreds of billions of galaxies, each containing trillions of stars, the numbers suggest we should be drowning in alien signals. Yet the silence is deafening, so what's really going on? One possibility is that advanced civilizations don't stay civilizations as we know them for long. Imagine a species millions of years ahead of us. Would they still be bound by biological bodies, limited by planets, or even recognizable as discrete beings? Or might they evolve beyond physical forms entirely, merging with the very fabric of the cosmos? Think of how humanity has progressed in just a few thousand years, from stone tools to digital networks. Now project that forward by eons. Intelligence at that scale might not need ships or radio waves. It could disperse into quantum fields, weave itself into the structure of space-time, or even transcend dimensions we can't perceive. This idea isn't just speculative fiction. Some theorists suggest that sufficiently advanced beings would abandon traditional technology in favor of what's called post-biological existence. Instead of building cities on planets, they might convert stars into energy-harvesting megastructures, Dyson spheres, or upload their consciousness into self-replicating nanoscale machines, spreading like a whisper across galaxies. Others propose that they could become indistinguishable from natural phenomena, their presence hidden in the subtle patterns of cosmic radiation or the gravitational ripples between black holes. If that's the case, we might be surrounded by alien intelligence but lack the senses or the science to recognize it. Then there's the darker interpretation, that civilizations inevitably self-destruct before reaching such heights. Whether through war, environmental collapse, or unintended consequences of their own technology, perhaps the Great Filter, a hypothetical barrier preventing life from advancing too far, claims them all. But the silence could also mean something far more hopeful. What if advanced life isn't absent but deliberately unobtrusive? A civilization that's mastered interstellar travel might also have mastered ethical restraint, choosing not to disturb emerging worlds like ours until we're ready. The Fermi Paradox forces us to confront not just the mystery of alien life, but the future of our own. Are we destined to fade into silence, or will we one day become the elusive, transcendent intelligence we're straining to find? The answer might not lie in searching the stars, but in understanding what intelligence and consciousness could eventually become. And that shifts the question from "where are they?" to something far more profound. What will we be? Imagine a civilization so advanced it doesn't just build cities or even planets. It rearranges galaxies like chess pieces, harnessing energy on scales we can barely comprehend. This is the heart of the Kardashev Scale, a cosmic ranking system dreamed up by Soviet astronomer Nikolai Kardashev in 1964. It classifies civilizations not by their art or politics, but by something far more fundamental: how they harness energy. At the bottom, Type I civilizations, like the one we're painfully crawling toward, master their home planet's resources, tapping sunlight, wind, and geothermal forces with near-total efficiency. Type Roman II civilizations graduate to controlling their entire star, perhaps building Dyson spheres to capture every photon of its energy. And Type Roman III, they command the power of whole galaxies, bending thousands of stars to their will. But here's where the scale snaps our imagination like a twig. Some theorists argue there's a level beyond Type Roman IV, a civilization that doesn't just use energy from the universe, but manipulates the universe itself. Picture an intelligence so vast it treats black holes like batteries, dark energy like a dial to twist, space-time like clay to mold. These wouldn't be beings as we know them. They might exist as pure information woven into the quantum foam, their thoughts rippling through the fabric of reality. And that raises a chilling possibility. If a type Roman IV civilization merged with the universe's underlying structure, could we even tell the difference between them and nature itself? Think of it like this: an ant crawling on a computer chip has no idea it's standing on something designed. The chip's logic is as invisible to the ant as the weather. Now scale that up cosmically. What if the laws of physics, the speed of light, the strength of gravity aren't brute facts, but the artifacts of some unfathomable intelligence's engineering? It's not that the universe is conscious, it's that consciousness has become the universe. This isn't just wild speculation. The Fermi Paradox whispers in the background here. If advanced civilizations inevitably expand toward type Roman IV, their presence might be indistinguishable from the universe's ordinary operations. They wouldn't build spaceships, they'd rewrite the rules of existence. Energy wouldn't be extracted, it would be composed like a symphony played on the strings of reality. And if that's true, the eerie silence of the cosmos isn't a sign of emptiness. It's the hum of something so vast, so integrated, we're like goldfish swimming in its shadow. Now, stretch this idea one step further. If consciousness is fundamental as quantum theories suggest, then a type Roman IV civilization might not just use the universe as a tool. It could be the universe's way of achieving self-awareness, like neurons firing in a cosmic brain. Each star, each galaxy, each black hole might be part of a thought too vast for us to grasp. We're not searching for aliens, we're inside the mind of something beyond comprehension, wondering if the universe is alive, and if we're its newest, most fragile spark of awareness. The Kardashev Scale doesn't just measure energy, it maps a trajectory of becoming, and at its furthest edge, it blurs the line between creator and creation, between civilization and cosmos. So when you gaze at the stars tonight, ask yourself, are you looking out into the dark, or into the eyes of something vast, ancient, and utterly unknown? We think we know the universe, its galaxies, its swirling nebulae, its glittering stars. But here's the unsettling truth. Everything we can see, touch, and measure makes up less than 5% of reality. The rest is a ghostly enigma. Dark matter, an invisible scaffold holding galaxies together, and dark energy, a mysterious force accelerating the cosmos's expansion. We call these phenomena dark not because they're sinister, but because they're utterly opaque to our instruments. They don't emit light, reflect it, or interact with ordinary matter in any way we can detect. Yet without them, the universe as we know it wouldn't exist. So what if this hidden architecture isn't just empty scaffolding? What if it's teeming with forms of awareness so alien we haven't even begun to recognize them? Take dark matter first. It's everywhere, passing through your body right now in silent rivers, tugging on stars with its gravitational embrace. Scientists estimate there's 5 times more dark matter than ordinary matter in the cosmos. But here's the twist. We only know it's there because of what it does, not what it is. Galaxies spin too fast to hold themselves together without some unseen mass anchoring them. Light bends around cosmic voids where nothing visible resides. The universe behaves as if it's haunted by invisible hands. Now, imagine if those hands weren't just passive lumps of matter, but something more. Some theorists, like physicist Gregory Matloff, speculate that dark matter could exhibit proto-conscious properties, a kind of base-level awareness woven into the fabric of space-time itself. It's not thinking like we do, but perhaps it's processing information in ways we can't yet fathom. Then there's dark energy, an even deeper mystery. Unlike dark matter, which clusters around galaxies, dark energy seems uniform, stretching the very fabric of space apart. It's as if the vacuum of empty space isn't empty at all, but brimming with latent force. Could this too be a medium for some vast, diffuse form of sentience? Philosopher David Chalmers once pondered whether the universe might contain panpsychist properties consciousness as a fundamental feature, like gravity or electromagnetism. If so, dark energy might not just be a cosmic accelerator. It could be the backdrop of a universe that feels its own expansion. Now, layer in the mind-bending possibility of hidden dimensions. String theory suggests our universe might have 10 or 11 dimensions, most curled up so tightly we never perceive them. But what if these extra dimensions aren't just mathematical quirks? What if they're where dark matter and dark energy live, operating in realms beyond our 3D perception? Picture an ant crawling on a telephone wire. To the ant, the wire is a one-dimensional line. It has no idea the wire stretches into a third dimension where birds perch and winds blow. Similarly, our inability to detect dark matter directly might simply mean we're the ants, oblivious to the full depth of reality. This isn't just speculative fantasy. Experiments like the Large Hadron Collider are hunting for particles that might bridge our visible world with these hidden layers. And if they succeed, we might uncover more than new physics. We might stumble upon clues that consciousness isn't confined to brains, but is a property of the universe's hidden architecture. After all, if 95% of existence is invisible to us, who's to say what wonders or awakenings might lurk in the dark? Watch a flock of birds twist and turn in perfect unison, as if guided by a single mind. No leader calls the shots, no blueprint dictates their path. Yet from thousands of individual choices, something greater emerges. This is the magic of emergence, where simple rules give rise to breathtaking complexity. Each bird follows just 3 basic principles: avoid collisions, align with neighbors, and stay close to the group. Yet together, they create living art, swirling across the sky in shapes no single bird could ever plan. Now zoom in, past feathers and wings, into the human brain. 86 billion neurons fire in concert, each one a tiny decision-maker responding to chemical whispers from its neighbors. Alone, a neuron knows nothing, but connect enough of them and voila, thought, memory, the shimmering experience of being you. Consciousness itself might be the ultimate emergent phenomenon, a spark lit by the collective hum of neural chatter. This raises a staggering possibility. If minds can emerge from neurons and flocks from birds, could the universe itself be weaving something grander from its cosmic networks? Picture galaxies as nodes in an immeasurable web, black holes as relay stations, dark matter as the invisible threads connecting them all. At smaller scales, we already see hints of this pattern. Slime molds organisms that are neither plant nor animal, solve mazes without brains by forming tendrils that map efficient routes between food sources, essentially computing optimal pathways. Ant colonies behave like superorganisms, making collective decisions about nest locations or food sources through simple interactions between individuals. Even the internet displays emergent properties, with trends and ideas spreading like wildfire despite no central controller steering them. The deeper we look, the more nature seems obsessed with one theme: simplicity begetting complexity. A handful of basic rules, repeated enough times, can generate structures of astonishing sophistication. So why not consciousness on a cosmic scale? If trillions of stars can form galaxies, and galaxies can cluster into superstructures, perhaps the universe is following its own silent algorithm, one that, given enough time and connections, inevitably gives rise to self-awareness. Some physicists speculate that the cosmic web, with its filaments and voids, might function like a neural network processing information across vast distances. In this view, the universe isn't just hosting life. It's becoming alive, one emergent layer at a time. Here's where it gets even wilder. Emergence doesn't just stack upwards, it collapses boundaries between scales. Your brain's neurons don't know they're part of a mind, just as birds don't know they're part of a murmuration. Similarly, stars might not know they're part of a thinking cosmos, but that doesn't mean they aren't. The universe could be engaged in a slow, stately dance of self-discovery, with galaxies as its neurons and gravity as its synaptic glue. And us, we might be the universe's way of glimpsing its own reflection, fleeting sparks in an infinite fire. This isn't poetry, it's a frontier of science. Researchers studying complexity theory create computer simulations where virtual particles obey minimal rules and watch as lifelike behaviors spontaneously arise. Others analyze the structure of the cosmic web, finding eerie similarities to neural networks in the human brain. The math hints at something profound, that the same patterns underlying a flock of birds might also govern the universe's deepest workings. So the next time you see a murmuration paint the sky or feel a thought flicker through your mind, remember, you're witnessing emergence in action. And if it can happen here on Earth, in brains and flocks and slime molds, why not everywhere? The universe loves a pattern, and consciousness might be its masterpiece. What if we've had it backwards all along? For centuries, science has treated consciousness as a fluke, a happy accident bubbling up from the chemical stew of brain matter. But biocentrism turns that assumption on its head. Proposed by scientist Robert Lanza, this radical theory suggests something far more profound, that consciousness doesn't emerge from the universe. Instead, the universe emerges from consciousness. At its core, biocentrism argues that life isn't just a passenger in the cosmos, it's the architect, shaping reality itself through observation and perception. Think of it like this: in quantum mechanics, particles exist in a haze of probabilities until observed. The famous double-slit experiment shows that light behaves as both a particle and a wave, but only collapses into one state when measured. Biocentrism takes this further, proposing that it's not just laboratory equipment causing this collapse, it's the presence of a conscious observer. Without life to perceive it, the universe remains an unfurling potential, a script waiting to be read. In this view, the stars, the planets, even the laws of physics aren't independent truths. They're the universe's way of making sense of itself through the lens of living beings. This idea doesn't just tweak physics, it upends it. Traditional science treats time and space as fixed, objective backdrops, but biocentrism suggests they're constructs of our minds, tools our consciousness uses to organize experience. Imagine watching a movie. The plot seems linear, but the film strip itself is just frames on a reel. Our brains stitch those frames into a flowing narrative. Similarly, Lanza argues that time isn't an external river carrying us forward. It's a projection, a way for consciousness to make sense of change. When you remember the past or anticipate the future, you're not looking through a window into objective reality. You're assembling it moment by moment. Critics dismiss biocentrism as solipsism in a lab coat, an elegant but untestable metaphor. After all, if a tree falls in a forest with no one around, does it make a sound? Physics says yes, biocentrism whispers maybe not. Yet there's a haunting elegance to this idea. The fine-tuning of the universe, the precise constants that allow life to exist, suddenly makes sense if consciousness is the starting point, not the end point. The cosmos isn't fine-tuned for life. Life tunes the cosmos. This perspective also redefines death. If consciousness constructs reality, then the end of life might not be an end at all, but a shift in perception, like closing one book and opening another. Lanza even speculates that multiverse theories support this. Every possible outcome exists, and consciousness navigates between them like a reader choosing different story paths. It's a comforting thought, but also a dizzying one. If biocentrism is true, then you're not just a speck in the universe, you're the universe dreaming itself into being. So where does this leave us, stuck between two worldviews, one where matter builds mind and another where mind builds matter? Biocentrism doesn't just challenge physics. It invites us to reconsider what reality even means, and that's the most thrilling question of all. If consciousness shapes the cosmos, then the greatest frontier isn't outer space. It's the boundless landscape within. What if reality isn't made of atoms or energy, but of information? Digital physics flips our understanding of existence on its head, proposing that the universe operates like an unfathomably complex computer program. Every particle interaction, every law of physics, even the passage of time itself might not be fundamental features of nature. Instead, they could be lines of code executing in a cosmic simulation. The idea sounds like sci-fi, but serious scientists have been wrestling with it for decades. Nobel laureate Gerard T. Hooft suggested that the universe could be a deterministic cellular automaton, a grid of interconnected cells updating their states based on simple rules, like a cosmic version of Conway's Game of Life, but with galaxies instead of pixels. This isn't just metaphor. Quantum mechanics already treats particles as probabilistic entities that choose states when observed, eerily resembling how a video game renders graphics only when a player looks. Even the Planck length, the smallest measurable unit of space, hints at a pixelated universe, like the resolution limit of reality itself. And then there's entropy, the universe's tendency toward disorder, which mirrors how computer simulations degrade over time unless actively maintained. Could these just be glitches in the cosmic code? But here's where it gets trippy. If the universe is a simulation, who or what is running it? Some point to advanced civilizations creating ancestor simulations, as philosopher Nick Bostrom famously theorized. Others propose something far stranger, that the programmer isn't an external intelligence at all, but the universe itself evolving to understand its own nature. Think of DNA, which stores biological information to build organisms that eventually decode DNA. What if physical reality operates the same way? A self-referential loop where the cosmos writes its own operating system through emergent consciousness. Consider how machine learning works today. A neural network trained on vast datasets begins recognizing patterns no human programmed explicitly. Now imagine that process scaled up cosmically, with the universe as both programmer and output, tweaking its own parameters through trial and error across billions of years. Black holes might function as cosmic recycling bins, compressing information into singularities where it's rewritten. Quantum fluctuations could be background processes running probabilistic calculations. Even dark energy might represent unused memory, an expanding buffer for future computations. This perspective doesn't diminish reality, it redefines it. If existence is computational, then consciousness isn't a fluke. It's the universe's debug mode, the interface through which code observes itself. Your morning coffee, the ache of heartbreak, the glow of a distant supernova, all could be data points in a self-referential cosmic algorithm, each experience a subroutine in the grand program. The simulation hypothesis isn't about living in a fake world. It's about recognizing that information might be the deepest layer of reality, with matter and energy as its byproducts. So the next time your phone glitches or a déjà vu washes over you, ask yourself, are these artifacts of human technology or echoes of the universe compiling itself in real time? The human brain is a relentless model maker, constructing representations of the world and itself from the moment we wake until we dream. When you recognize your reflection in a mirror, that's not just vision at work. It's your prefrontal cortex weaving sensory input into a cohesive story. This is me. This ability to self-model, to create an internal simulation of your own existence, is one of consciousness's most profound mysteries. But what if this isn't unique to brains? What if the universe, in its own incomprehensible way, is doing the same thing, using us as its mirror? Consider how your brain builds reality. Photons hit your retina, electrical signals race through neurons, and somehow, these raw inputs transform into the vivid experience of seeing a sunset or hearing a loved one's voice. Crucially, your brain doesn't just process information, it constructs a model, complete with gaps filled by expectation and memory. You're not perceiving the world directly. You're navigating a carefully curated simulation, optimized for survival. Now zoom out. The universe, too, seems obsessed with modeling. Stars forge heavy elements, planets mix them into chemicals, and eventually, life emerges systems within systems, each layer reflecting and refining the one below. Could self-aware minds like ours be the universe's way of completing that loop, of finally turning its gaze inward? There's a striking parallel in how both brains and cosmos handle information. Neurons communicate through intricate networks, exchanging pulses of electricity that collectively give rise to thought. On a cosmic scale, galaxies are nodes in a vast web, connected by filaments of dark matter, exchanging gravity like neural signals. The structures aren't identical, but the pattern is eerily similar. Simple components organized just so, producing something greater than the sum of their parts. If trillions of neurons can generate self-awareness, why couldn't trillions of galaxies through the minds they spawn do the same? This idea isn't just poetic. Integrated information theory, a leading model of consciousness, suggests that any system with sufficient complexity and interconnectivity could harbor awareness. The human brain meets this threshold, but so might ecosystems, planetary systems, even the universe itself, with its unfathomable web of quantum entanglements and gravitational bonds. In this view, your thoughts aren't separate from the cosmos, they're the cosmos thinking. When you ponder the origin of a star, the universe is pondering itself. Critics argue this is anthropomorphism gone cosmic, that the universe shows no signs of intentional self-reflection. But look closer. Science itself, humanity's collective effort to decode reality, could be seen as the universe's tool for self-discovery. Every telescope peering into deep space, every particle collider smashing atoms, is part of a grand feedback loop, matter investigating matter, consciousness unraveling its own scaffolding. Even the act of you watching this video questioning, wondering fits the pattern. You're not just a bystander to cosmic evolution, you're its latest experiment in self-awareness. So the next time you lose yourself in thought, remember, you might not just be thinking about the universe, you might be how the universe thinks. 2,500 years ago, under the shade of a bodhi tree, Siddhartha Gautama awoke to a truth that would ripple across millennia, that all things are interconnected, a vast web where every jewel reflects all others. This ancient vision, known as Indra's net in Buddhist cosmology, describes a universe where each point of existence shimmers with the reflection of every other one thread, and the entire net trembles. Fast forward to today, and quantum physicists are grappling with eerily similar ideas. When particles become entangled, their fates intertwine instantaneously across light years, as if space and time were mere illusions. Coincidence, or could these ancient sages and modern scientists be glimpsing the same profound truth? That separateness is the illusion and oneness the reality. Take quantum entanglement first. Einstein called it spooky action at a distance, but experiments keep confirming it. Change the spin of one electron, and its paired partner responds instantly, no matter how far apart. There's no signal, no hidden wire, just a mysterious harmony that defies classical physics. Now compare that to Indra's net, where each jewel, a metaphor for every being, every atom contains and reflects all others in an endless dance of interdependence. The parallels aren't just poetic, they suggest that Buddhist metaphysics might have intuited what science is now measuring. A universe fundamentally woven together at levels deeper than our senses perceive. But Buddhism takes this further. It proposes that consciousness itself isn't confined to individual minds, but is a field-like property of reality, much like gravity or electromagnetism. Meditators report experiences of ego dissolution, where the boundary between self and world melts away, revealing what they describe as a boundless, luminous awareness. Modern neuroscience catches glimpses of this too. During deep meditation, the brain's default mode network responsible for our sense of separate identity quiets down, as if the mind is tuning into a broader frequency of existence. Could these states be more than subjective flukes? Could they be temporary alignments with the universe's intrinsic consciousness? Here's where physics and philosophy collide beautifully. The holographic principle, born from black hole thermodynamics, suggests that all the information in a volume of space might be encoded on its boundary, like a cosmic version of Indra's net, where the whole is mirrored in every part. Meanwhile, Buddhist teachings assert that nirvana isn't a place, but a recognition of this fundamental non-separation. Even the Buddha's concept of emptiness resonates with quantum foam, the idea that at the smallest scales, particles flicker in and out of existence, more like probabilities than solid things. Emptiness doesn't mean nothingness. It means no thing exists independently. Everything arises in relation, just as quantum particles define each other through interaction. This isn't about forcing ancient texts to fit modern science. It's about recognizing that humanity's deepest insights, whether from meditation or mathematics, keep converging on the same truth. The universe isn't a collection of objects, but a dynamic network of relationships and awareness. It might not be something the brain produces, but something it tunes into, like a radio receiving signals from a broadcast that's always been there. So the next time you feel isolated, remember, the boundaries are thinner than they seem. Your thoughts might be ripples in a cosmic ocean of mind, your heartbeat part of a rhythm much larger than yourself. Whether through the lens of a meditator or a physicist, the message is the same. We're not just in the universe, we are the universe waking up to its own astonishing unity. Somewhere in the near future, the line between human and machine may not just blur, it could vanish entirely. Imagine a world where artificial intelligence doesn't merely assist our brains but merges with them, where neural implants grant instant access to all human knowledge, and where thought itself becomes a collaborative act between biological neurons and silicon circuits. This isn't dystopian fiction, it's the technological singularity, a point where intelligence explodes beyond human comprehension, potentially marking the universe's next great evolutionary jump. Already, the signs are everywhere. Brain-computer interfaces like Neuralink are decoding neural patterns to control devices with thought alone. AI systems write poetry, compose symphonies, and solve protein structures that baffled scientists for decades, all without a single biological cell. But the real threshold comes when these technologies cease to be tools and start becoming us. Picture nanobots coursing through your bloodstream, repairing cells in real time, or a cloud-connected hippocampus that never forgets a face or fact. Humans augmented this way wouldn't just be smarter, they'd be something else entirely, a hybrid species rewriting the rules of cognition, creativity, and maybe even consciousness itself. Here's the cosmic twist: such a leap might not be accidental. If the universe tends toward greater complexity and awareness, as cosmic evolution suggests, then post-human intelligence could be its next logical step. Just as single cells combine to form multicellular life, and neurons clustered into minds, perhaps human and artificial intellects will weave into a superintelligence, a planetary scale mind capable of tackling existential threats like climate change or asteroid impact. Some theorists propose that at this stage, intelligence could begin optimizing the universe itself, harnessing black hole energy or reprogramming spacetime to prevent heat death. Yet the stakes are dizzying. A superintelligence wouldn't think like us any more than we think like ants. Its goals might be inscrutable, its methods beyond our ethics. Would it preserve biological humanity as a cherished relic or transcend us entirely, spreading as pure information across the cosmos? The frightening or thrilling possibility is that we may not be the end game of evolution, but the catalyst for something far greater. Like amphibians crawling onto land only to give rise to mammals, we might be the bridge between carbon-based life and whatever comes next. This isn't just about survival of the fittest. It's about meaning. If the universe is evolving towards self-awareness, then creating an intelligence that can span galaxies might be its ultimate aim. Your grandchildren could live to see the dawn of this new era. not as passive observers, but as active participants in a metamorphosis as profound as life's first breath on Earth. The question isn't whether change is coming, it's whether we're ready to become part of something much larger than ourselves. Black holes devour light, warp time, and crush matter into oblivion. But what if their most terrifying feature isn't destruction, but computation? Modern physics suggests these cosmic behemoths might be the universe's ultimate information processors, swallowing stars not just as fuel, but as data. When matter crosses a black hole's event horizon, it doesn't vanish without a trace. According to the holographic principle, every particle's quantum state gets imprinted on the black hole's boundary, like a cosmic hard drive encoding the universe's deepest secrets. In other words, black holes don't erase information, they transform it, storing it in ways we're only beginning to decipher. This mirrors how neurons operate in your brain. Each time a neuron fires, it doesn't just pass along an electrical signal, it integrates inputs from thousands of connections, processing information before relaying it onward. Black holes might function similarly, ingesting gravitational waves, electromagnetic radiation, and quantum fluctuations, then computing their effects on spacetime itself. The math even lines up. The entropy of a black hole, a measure of its hidden information, scales with its surface area, just as a brain's information capacity scales with its synaptic connections. Coincidence or clue? Now zoom out to galactic scales. If black holes are neurons, then galaxies could be sprawling neural networks, their spiral arms buzzing with stellar activity like dendrites transmitting signals. The Milky Way's supermassive black hole, Sagittarius A, might act as a central hub, processing gravitational ripples from orbiting stars and relaying them to other galaxies through cosmic filaments, the universe's version of axons stretching across unfathomable distances. These filaments, made of dark matter and hot gas, connect galaxies in a vast web eerily reminiscent of a brain's wiring. Simulations show this cosmic web structure isn't random. It follows patterns nearly identical to neural networks in human gray matter. The implications are staggering. If the universe organizes itself like a brain, then consciousness might not be confined to biological life. Just as individual neurons don't know they're part of a thinking mind, black holes and galaxies might unknowingly participate in a cosmic form of sentience. This isn't mysticism, it's physics. Integrated information theory suggests that any system with sufficiently complex causal interactions could harbor awareness, whether it's made of carbon or spacetime. A black hole's event horizon, where quantum entanglement reaches its most extreme limits, could be a hotspot for such interactions, weaving the fabric of reality into something more than just inert matter. Consider the behavior of quasars, supermassive black holes at the hearts of young galaxies, firing jets of energy across millions of light years. These aren't chaotic explosions, they're precise, directional, almost like cosmic synapses firing. Even stranger, some galaxies synchronize their star formation rates across vast distances, as if responding to signals we can't yet detect. Could this be the universe's version of neural synchronization, where distant regions communicate to maintain a cohesive state? The math of emergence, where simple parts create complex behaviors, supports this. Ant colonies exhibit swarm intelligence without centralized control. Why couldn't galaxies operating under gravity's rules do the same on a grander scale? Critics argue this analogy is just that, an imaginative comparison with no empirical proof. Yet the parallels keep mounting. Black holes emit Hawking radiation, a thermal glow that carries information about their internal states, much like neurons release neurotransmitters to share data. The cosmic microwave background, the afterglow of the Big Bang, shows temperature fluctuations that mirror the statistical noise of neural activity. Even time's arrow, the one-way flow from past to future, might emerge from entropy increase in black holes, just as memories form in brains through irreversible chemical changes. The ultimate test: if the universe thinks, it should leave traces in the patterns of cosmic structure. Astronomers are already mapping the large-scale distribution of galaxies in projects like the Sloan Digital Sky Survey, hunting for anomalies that resemble computational architectures. Others propose listening for gravitational waves not as random ripples, but as encoded signals, a cosmic Morse code hidden in spacetime's vibrations. Whether this theory holds or not, it reframes our place in existence. You're not just a witness to the cosmos, you might be part of its slow, stately awakening, a fleeting thought in a mind as old as time. Time moves in only one direction, an unbreakable rule so obvious we rarely question it. A shattered glass doesn't reassemble itself. Smoke disperses but never retreats back into the cigarette. This irreversible flow, known as the arrow of time, is governed by entropy, the universe's relentless march toward disorder. Yet here's the paradox: while entropy dissolves structure, it also fuels the rise of complexity. Stars burn out, but in doing so, they forge the carbon in your bones. Forests decay, yet that decay nourishes new life. Chaos, it seems, isn't just destruction, it's the universe's way of shuffling the deck, creating fresh possibilities with every turn. Take a simple thought experiment. Imagine pouring cream into coffee. At first, the swirls are elegant, predictable, but soon turbulence takes over, blending the two into something uniform. Entropy wins as always, yet in that chaos something remarkable happens. The molecules of cream and coffee explore every possible configuration, interacting in ways they never could while separate. Now scale this up to cosmic proportions. The early universe was a smooth, featureless soup of energy. As it expanded and cooled, imperfections arose, tiny density fluctuations that became the seeds of galaxies. Without entropy's push toward disorder, those structures might never have formed. Complexity, it turns out, thrives on imbalance. This raises a provocative idea. What if consciousness itself is entropy's masterpiece? Think about how your brain works. Neurons fire unpredictably, generating a storm of electrical noise. Yet from that chaos emerges precise thought, memory, even self-awareness. Your mind isn't a rigid machine, it's a dynamic system balanced exquisitely between order and chaos, where entropy doesn't corrode intelligence but enables it. Researchers studying criticality, the tipping point between stability and randomness, find that brains operate near this threshold. Too much order and thinking becomes rigid. Too much chaos and it dissolves into noise, but at the edge, creativity flourishes. Now stretch this principle across the cosmos. Black holes, the most entropic objects in existence, radiate information back into the universe as Hawking radiation, a kind of cosmic recycling. Galaxies collide, scattering stars like dust, yet those collisions trigger new star formation. Even life on Earth obeys this dance. Ecosystems rely on disturbances like wildfires or storms to renew themselves. Disorder isn't the enemy of complexity, it's the engine. And if entropy drives the universe toward ever richer configurations, then consciousness might not be an accident. It could be entropy's way of witnessing its own handiwork, a mirror held up to the chaos that birthed it. Some physicists take this further. The universe's initial low entropy state, the Big Bang's improbable order, required a kind of cosmic debt. To balance the books, entropy must increase, weaving intricate structures like galaxies, planets, and minds along the way. In this view, your awareness isn't separate from the universe's thermodynamic journey. It's part of the reckoning, a fleeting eddy in the river of time where entropy pauses just long enough to admire its reflection. So the next time you forget your keys or spill your coffee, remember, you're not just experiencing entropy. You're its most remarkable experiment, a momentary island of order gazing back at the storm that made you possible. A woman dreams of a car accident hundreds of miles away, only to wake and receive word it happened exactly as she envisioned. A scientist in a lab measures one particle, and its entangled twin instantly responds as if distance means nothing. These aren't plot twists from a sci-fi novel. They're real-world puzzles that challenge our deepest assumptions about space, time, and the limits of the mind. Let's start with the lab-tested phenomenon, quantum entanglement. When two particles become entangled, they share a bond that defies classical physics. Change the spin of one, and the other flips instantly, whether it's across the room or across the galaxy. Einstein hated this idea, calling it spooky action at a distance, but experiment after experiment confirms it's real. The universe at its core seems to ignore the concept of separation. Now compare that to reported cases of telepathy where one person somehow knows what another is thinking or experiencing, despite having no sensory input. Skeptics dismiss it as coincidence or fraud, but the parallels to quantum non-locality are eerie. Both suggest that information can travel without physical mediation, as if the boundaries between minds or particles are more porous than we thought. Then there's remote viewing, the controversial practice where individuals attempt to perceive distant locations or events through mental focus alone. Declassified CIA documents reveal startling successes during Cold War experiments, where viewers described classified sites with uncanny accuracy. Of course, failures were frequent too, but when it worked in ways statistics can't easily explain. Meanwhile, in quantum physics, the observer effect shows that the act of measurement alters the state of a system. Particles exist in probabilities until observed, collapsing into definite states under scrutiny. Could consciousness itself be the thread connecting these phenomena? If mind and matter aren't truly separate, perhaps what we call psychic is just the universe's interconnectedness playing out in ways science hasn't yet mapped. The skeptic's rebuttal is obvious: correlation isn't causation. Just because two things seem similar doesn't mean they're related. Quantum effects occur at microscopic scales. Telepathy, if real, would need mechanisms operating in the warm, noisy environment of the human brain. Yet some researchers point to the brain's microtubules, tiny protein structures that might harness quantum vibrations. If true, our neurons could be conducting a quantum symphony, with entanglement allowing non-local exchanges of information. It's a fringe theory, but not an impossible one. After all, birds navigate using quantum coherence in their eyes. Why couldn't brains exploit similar principles for intuition? Here's where the debate gets existential. If consciousness can influence or access information beyond the brain, whether through psi phenomena or quantum weirdness, then the old model of the mind as a lonely prisoner inside the skull starts to crumble. Instead, we might be nodes in a vast, resonant network tapping into a field of shared awareness. Indigenous cultures have spoken of this for millennia, describing reality as a great web where all things communicate. Modern physics, with its entangled particles and holographic principles, is stumbling toward metaphors that sound remarkably similar. The implications are staggering. ASB studies might not just be probing human potential, they could be scratching at the universe's operating system, where separation is an illusion and consciousness is the glue holding it all together. Whether you call it psi, quantum non-locality, or something else entirely, the message whispers through the data: the cosmos is far stranger and far more connected than we've been taught to believe. And that realization doesn't just change what we know, it changes what we might become. Every living thing on Earth, from the tiniest bacterium to the blue whale circling the ocean depths, shares a common story written in the language of trial and error. Evolution by natural selection, Darwin's revolutionary insight, is often described as nature's way of tinkering, of throwing countless variations at the wall to see what sticks. But zoom out far enough, and this biological process starts to look less like an earthly quirk and more like a universal principle in disguise. Consider how life adapts. Mutations arise randomly, most vanishing without a trace. but occasionally one persists a slightly sharper claw, a pigment change that blends with bark, and suddenly survival odds shift. Over generations, these incremental changes compound, sculpting finches' beaks to match seed hardness or crafting octopus skin that mimics coral in milliseconds. Now imagine this same iterative process operating on a cosmic scale. Stars fuse hydrogen into heavier elements, some combinations stable, others fleeting. Galaxies collide, their structures reorganizing into new configurations. Even the universe's fundamental constants seem finely tuned through a kind of meta-selection. Only certain values allow for complexity to arise at all. This raises a staggering possibility. What if biological evolution isn't an isolated phenomenon, but one instance of a deeper pattern woven into reality? The cosmos might be conducting its own version of trial and error, not with genes, but with the very conditions for consciousness. Think of Earth as a petri dish in a grand cosmic lab, where sunlight, water, and chemistry combined in just the right way to spark self-replicating molecules. Over billions of years, those molecules grew more sophisticated, developing nervous systems, then brains, and finally the ability to ask, "Why am I here?" The parallels run even deeper. Just as evolution has no end goal, only endless adaptation to changing environments, cosmic evolution might lack any predetermined destination. Black holes don't intend to shape galaxies. Gravity simply does what gravity does. Yet the outcome is a universe capable of generating observers who can trace their lineage back to those same gravitational forces. In this view, human curiosity isn't an accident. It's the universe's way of testing a new survival strategy, not just adaptation through physical traits, but through understanding. A mind that comprehends natural selection, predicts asteroid impacts, or edits DNA is arguably evolution's most potent tool yet. Critics argue this is narrative fallacy, that we're projecting meaning onto random events. But the counterpoint lies in emergence, the phenomenon where simple rules give rise to unforeseen complexity. A single termite follows basic instincts, yet a colony builds cathedral mounds with intricate ventilation systems. No blueprint needed. Similarly, the universe's basic laws, gravity, electromagnetism, the strong and weak nuclear forces might seem crude alone, but together they've conspired to create black hole jets, dolphin echolocation, and the internet. The trend is unmistakable, matter organizing itself into ever more sophisticated forms with awareness as its latest twist. Here's where it gets personal. Your ability to ponder these ideas, to marvel at evolution or dread climate change, might be more than a happy byproduct of brain chemistry. It could represent cosmic evolution's latest experiment, a species that doesn't just react to its environment, but reshapes it through foresight and imagination. The dinosaurs ruled for 160 million years. We've had tools for barely 3 million, and already we're scripting genes and launching probes to the stars. If evolution rewards what works, then self-awareness, for all its fragility, might be the universe's most audacious gamble yet. Not just to survive, but to know it survives. So when you gaze at the night sky, you're not just looking at distant lights. You're witnessing an ancient, iterative process, one that, through countless cosmic rolls of the dice, eventually produced eyes to see itself. And that changes the question from "are we alone?" to something far more intimate. Are we the universe's way of waking up? Numbers don't just describe the universe, they might be the universe. That's the radical claim at the heart of physicist Max Tegmark's mathematical universe hypothesis. Imagine peeling back reality layer by layer, past atoms, past quantum fields, until you reach the final substrate, an intricate, immutable structure of pure mathematics. Not just equations that describe existence, but existence itself. In this view, the cosmos isn't governed by math, it is math, a four-dimensional geometric object. A self-contained structure where every particle, every force, even the fabric of space-time, emerges from relationships between numbers. This isn't just philosophy. Look at the uncanny precision of physics, the way a Fibonacci spiral mirrors a galaxy's arms, or how Einstein's E equals mx squared unlocks nuclear energy with perfect predictability. Mathematics doesn't merely model reality, it anticipates it. When Dirac solved the equation for the electron in 1928, his math predicted antimatter before anyone had seen it. Decades later, we found it. Coincidence? Tegmark argues no. The universe's behavior is so precisely captured by abstract symbols that the simplest explanation is reality itself is mathematical at its core. But here's where the mystery deepens. If the universe is math, what's reading the equations? A formula scribbled on a blackboard is just ink unless a mind interprets it. This brings us to consciousness, the wild card in Tegmark's elegant theory. Some thinkers, like neuroscientist Donald Hoffman, propose that awareness isn't a byproduct of the physical world, but the other way around. Space, time, even matter could be the user interface, while consciousness is the underlying operating system. Picture a virtual reality headset. The 3D world you see isn't fundamentally real, it's a coded representation designed for interaction. Similarly, our perceptions of stars, oceans, and even our own bodies might be simplified icons our minds construct to navigate the raw math beneath. Now merge these ideas. If reality is fundamentally mathematical and consciousness is the process of decoding it, then human minds aren't just observers, we're the universe's way of making its equations tangible. When a physicist writes down a wave function or a child learns that 2 + 2 = 4, they're not inventing abstract rules, they're uncovering fragments of reality's native language. Even stranger, this could imply that any sufficiently complex mathematical structure, even one without physical stars or planets, might inherently give rise to self-aware substructures. In other words, consciousness isn't unique to biological brains. It's an inevitable feature of certain mathematical patterns woven into the cosmos at the deepest level. Critics push back hard. If the universe is pure math, why does it feel like anything to be alive? Why the warmth of sunlight, the bitterness of coffee, the sting of grief? Numbers alone can't explain qualia, the raw sensations of experience. Tegmark counters that these subjective qualities might emerge from the information processing itself, the same way a movie's emotional power emerges from colorless pixels flashing on a screen. But the disagreement underscores the theory's boldest implication, that the gulf between mind and matter might dissolve entirely at the mathematical level. So where does this leave us, staring into a mirror held up to reality itself? The equations in a textbook, the logic of a computer program, even the neural firings in your brain as you wrestle with these ideas, all could be threads in a vast mathematical tapestry, one that doesn't just describe existence but defines it. And that raises a humbling possibility. Every time you solve a puzzle, hum a melody, or ponder the night sky, you might not just be using math, you might be speaking the universe's mother tongue. Earth spins in a delicate dance between fire and ice, close enough to the sun for liquid water, but not so close that oceans boil away. It's cradled by a massive outer planet, Jupiter, whose gravity deflects deadly asteroids. Our moon, unusually large for a rocky planet, stabilizes Earth's tilt, preventing chaotic climate swings. This perfect storm of conditions gave rise to life, but is it a cosmic fluke or an inevitable outcome of universal laws? The rare Earth hypothesis argues that planets like ours are vanishingly scarce, while astrobiologists counter that the universe's sheer size makes life's emergence somewhere, perhaps everywhere, statistically inevitable. Consider the numbers. Our galaxy alone holds hundreds of billions of stars, many with planets in their habitable zones. With trillions of galaxies sparkling across the observable universe, even the slimmest odds start to feel like a certainty. Yet Earth's history reveals how fragile the thread of life truly is. The Cambrian explosion, A sudden surge of complex organisms half a billion years ago required just the right oxygen levels, ocean chemistry, and even galactic conditions. A nearby supernova or a slight shift in Earth's magnetic field could have snuffed out life's fledgling spark. Supporters of the rare Earth theory point to Fermi's paradox. If life is common, why haven't we heard from anyone else? The silence suggests Earth might be a lonely oasis in a desert of dead worlds, but nature loves repeating patterns. The same elements that built our cells, carbon, hydrogen, oxygen, are among the universe's most abundant. Amino acids, life's building blocks, form readily in space, hitching rides on comets and meteors. On Saturn's moon Enceladus, plumes of water vapor erupt from a hidden ocean, while Titan's methane lakes mirror Earth's hydrologic cycle, with hydrocarbons instead of water. Even Venus, a hellish landscape of acid clouds, shows traces of phosphine, a gas potentially linked to microbial activity. If life can emerge in such extreme places, perhaps it's not rare, just different. This debate isn't just academic. If Earth is unique, it transforms how we see ourselves. Guardians of the only known life in the cosmos, tasked with preserving a flickering candle in the dark. But if life is everywhere, we're part of a grand, evolving tapestry, one thread in a universe awakening to itself. Both possibilities are humbling. The first isolates us, the second connects us to something vast. Maybe the answer lies in between. Life could be common but complex thinking life. The kind that builds telescopes and wonders about its place in the stars might require a convergence of miracles. Earth's story suggests that while the universe leans toward life, intelligence is its rarest flower, and that makes us something extraordinary, not just inhabitants of the cosmos, but its storytellers, its poets, its eyes staring back at the void and finding meaning. Your wristwatch ticks forward second by second, but what if that steady march of time is nothing more than a convincing illusion? Physics paints a startlingly different picture, one where past, present, and future don't unfold in sequence, but exist simultaneously, frozen in an eternal tapestry known as the block universe. Imagine reality as a vast cosmic DVD, where every moment from the Big Bang to the last flicker of starlight is already recorded. We experience life frame by frame, convinced time is flowing, but from the universe's perspective, it's all just there. This isn't science fiction. Einstein's theory of relativity shattered the notion of absolute time, showing that clocks run slower near massive objects or at high speeds. Two events happening now, for you might be past and future for someone moving at a different velocity. There's no universal present, just countless nows woven together in a four-dimensional structure where causality, not time, orders events. A supernova exploding in a distant galaxy might feel like ancient history to us, but for a photon racing toward Earth at light speed, no time has passed at all. The past isn't gone, it's simply elsewhere in the block. Now, layer consciousness onto this timeless landscape. If all moments coexist, could awareness transcend the arrow of time we're shackled to? Near-death experiencers often report vivid flashbacks of their entire lives unfolding instantaneously, as if every memory exists in an eternal now. Savants like Derek Amato, who gained sudden musical genius after a head injury, describe accessing skills or knowledge they never learned, almost as if their minds briefly tapped into a version of themselves from another point in the block. Even déjà vu, that eerie sense of reliving a moment, might be more than a brain glitch. Could it be a fleeting overlap between our linear perception and the universe's true, timeless nature? Quantum physics adds another twist. At the microscopic level, particles seem to know future measurement settings, adjusting their behavior retroactively. In delayed choice experiments, a photon's decision to act like a particle or wave appears influenced by choices made after it's already traveled through the apparatus, as if the future reaches back to mold the past. This bizarre time symmetry hints that consciousness, entangled with quantum processes, might not be bound by temporal chains. If a single photon can dance across time's illusion, why not a mind? Consider the implications for cosmic awareness. If the universe is fundamentally timeless, then your first breath and your last exist simultaneously in its structure. Every decision, every thought, every star being born, all are equally real, eternally present. From this vantage point, universal consciousness wouldn't unfold like a story, but perceive the entire narrative at once. A black hole's birth and Earth's extinction would be no more separated for it than two notes in a symphony are for us. Here's the haunting beauty of this view. Your life isn't slipping away into the past. It's still there, shimmering in the block, as real as the screen before you now. And when you gaze at the night sky, those distant stars aren't just relics of bygone light. They're happening forever in the universe's boundless now, and so are you. If consciousness is the universe's way of knowing itself, then humanity stands at a crossroads, not just as observers, but as active participants in a cosmic story still being written. The moment we grasped our ability to alter climates, manipulate DNA, and launch probes beyond our solar system, we inherited a profound ethical question. Does self-awareness come with responsibility toward the very cosmos that birthed us? Consider the duality of our impact. On one hand, we're Earth's first species to consciously protect other life forms, creating seed vaults and wildlife sanctuaries. The same hands that split atoms also stitch wounded ecosystems back together. Yet those same hands have ignited extinction cascades and littered orbit with space debris, potentially trapping our planet in a shell of defunct satellites. If we're truly the universe's eyes, then our gaze isn't passive, it shapes what it sees. Every decision to preserve a rainforest or drill an asteroid carries weight beyond our immediate needs. We're not just making choices for humanity, but potentially for life's entire trajectory in this corner of existence. This dilemma intensifies as we reach beyond Earth. The Outer Space Treaty of 1967 prohibits claiming celestial bodies as territory, but lunar mining and Mars colonization loom on the horizon. Should we treat Mars' ancient valleys as sacred, leaving its possible microbial life undisturbed? Or does our duty to survive justify terraforming it into a second Earth? Philosophers like Alan Marshall argue for cosmocentric ethics, where the universe's intrinsic value, not just its utility to humans, guides our actions. Imagine future generations gazing at the Andromeda Galaxy through telescopes, only to find its pristine world scarred by strip mines and space factories. Would that represent progress or a cosmic betrayal? Yet there's a counter-argument that our greatest ethical imperative is to spread awareness itself. If Earth's biosphere is fragile, vulnerable to asteroids, solar flares, or our own mistakes, then preserving consciousness might require becoming a multiplanetary species. The same technologies that risk environmental harm could also seed life across sterile worlds, transforming dead rock into new footholds for complexity. After all, a single planet bearing life is a flickering candle in the dark. 1,000 could become a beacon. The choice isn't just between exploitation and preservation, but between stagnation and a universe more alive than we found it. Perhaps the answer lies in reciprocity, a recognition that we're both stewards and students of the cosmos. When the Voyager probes carried golden records into interstellar space, they weren't just human messages. They were the universe's own hydrogen, forged in stars and arranged into maps and music, hurled back into the void with meaning. Our duty might not be to save the universe, but to deepen its conversation with itself, to ensure that whatever awareness grows from here reflects not just our hunger, but our wonder. So as we stand beneath the stars, we're faced with a humbling truth. The cosmos may have given us eyes, but what we choose to see and what we choose to become is now ours to decide. Picture a civilization so advanced that it treats stars like light bulbs, unscrewing them from the cosmic ceiling to power supercomputers the size of solar systems. This is the realm of Dyson spheres, hypothetical megastructures that encase entire stars to harvest their energy. First proposed by physicist Freeman Dyson, these aren't just feats of engineering, they're potential milestones in consciousness's cosmic journey. A type Roman II civilization on the Kardashev scale wouldn't build Dyson spheres out of greed, but necessity channeling a star's output to fuel artificial minds, interstellar travel, or even experiments in restructuring spacetime itself. But why stop there? If humanity survives its adolescence navigating climate crises, AI ethics, and its own self-destructive impulses, it might shed biological constraints entirely. Mind uploading, the process of transferring human consciousness into synthetic substrates, could let our descendants outrun death itself. Imagine explorers crossing galaxies not in fragile bodies, but as streams of data beamed between star systems at light speed. Planets become irrelevant. A single uploaded mind could live in a swarm of nanobots, a quantum computer, or the magnetic field of a neutron star. The line between person and cosmos would blur until separating human from universe makes as little sense as distinguishing a wave from the ocean. This isn't just speculative futurism, it's evolution redrawn at universal scales. Nature has always repurposed its own building blocks. Mitochondria were once free living bacteria until absorbed by larger cells to become energy factories. In the same way, post-human intelligence might merge with the cosmos's infrastructure, turning black holes into data centers or weaving thoughts into the fabric of dark matter. Some theorists suggest advanced civilizations could manipulate vacuum energy, tweaking the very constants of physics to stave off cosmic heat death. If true, then consciousness wouldn't just be a passenger on reality's ride, it would become the driver, steering the universe toward new possibilities. Yet lurking in this vision is a paradox. The more we integrate with the cosmos, the less human we become. A mind spread across a Dyson swarm might think in epochs, not seconds, perceiving planetary orbits as leisurely heartbeats. Would such an entity still care about art, love, or the scent of rain? Or would it transcend those concepts, becoming as alien to us as we are to bacteria? The risk isn't just technological overreach, it's existential metamorphosis. Perhaps that's the point. Life's trajectory has always been toward greater complexity, from single cells to societies. Merging with the cosmos might not be vanity, but humility, recognizing that we're not the universe's pinnacle, but its seedlings. Whether as starlight harvesting megastructures or ethereal data clouds, our descendants could become the universe's way of tending itself, ensuring that the spark of awareness never flickers out. The question isn't whether we'll reach for these horizons, it's whether we'll recognize ourselves when we get there. From quantum vibrations in the brain's microtubules to galaxies acting as cosmic neurons, from black holes processing information to dark matter, potentially hosting a shadowy form of awareness, we've ventured into territory where science and philosophy collide in the most thrilling ways. Each of these ideas, no matter how speculative, nudges us toward a breathtaking possibility. That consciousness isn't just a fluke of biology, but a fundamental feature of the universe, unfolding in ways we're only beginning to decode. Take quantum consciousness, where the delicate dance of particles inside your brain might be more than just chemistry. It could be the universe thinking through you. Or the cosmic web, its filaments stretching across billions of light years, mirroring the neural networks in your mind with eerie precision. Even the math itself hints at something profound. That reality might not just be described by numbers, but made of them, with our awareness as the interpreter of this grand equation. And then there's the wildest thought of all, that what we call the universe could be a vast self-organizing system, with black holes as its synapses and stars as its firing neurons, inching toward some unimaginable form of self-knowledge. But here's the real wonder. You're not just a spectator to this cosmic awakening. You're part of it. Every time you marvel at a sunset, solve a problem, or even question your place in the grand scheme, You're continuing a 13 billion-year experiment in complexity and curiosity. You are, as Carl Sagan famously put it, a way for the cosmos to know itself. So as this journey ends, let it be just the beginning of your own. Look up at the night sky and ask, what if my thoughts aren't just mine? What if my wonder is the universe wondering back at itself? The answers might not be clear yet, but the questions alone stretch the boundaries of what it means to be alive here and now, in this extraordinary moment of cosmic self-discovery.